Imagine you're driving across a country you've never visited. Thousands of possible roads, thousands of possible turns. Yet somehow you arrive exactly where you intended. Not by luck, but because someone continuously guided your journey. Now imagine doing the same thing, not with one car, but with billions, every second, without traffic lights, without police, without anyone watching the roads. It sounds impossible, yet that's exactly what the internet does. Every photo, every email, every video, every AI request, every online payment travels through countless intersections, making thousands of decisions before reaching its destination. Most people think data simply moves. But here's the question: who decides which road it should take? Because after DNS finds the destination, the journey is only beginning. Someone must choose the path. Quietly, instantly, billions of times every single day. Today, we're uncovering the invisible machines quietly guiding every journey across the internet. Because without them, the internet wouldn't know where to go.
Imagine standing at a crossroads. One road heads north, another heads south, another crosses the mountains. Only one leads to your destination. Someone has to decide which road you should take. The internet faces the same decision every second. Every request eventually reaches an intersection. Not a road intersection, a network intersection. A place where one connection meets another. Most people never imagine these intersections. Yet without them, the internet could never scale to billions of people. Because every network eventually connects to another network, and every connection creates another decision. Should the data go left, go right, continue forward, or choose an entirely different route? Most people believe data simply follows a cable. Architects know data makes decisions at every intersection. Those decisions must happen almost instantly, not once, but billions of times every single second. That's where another machine quietly begins its work. A machine designed for one purpose: not to store information, not to process applications, not to translate names, but to answer one simple question: where should this go next? That machine is called a router. And without it, the internet wouldn't be a network. It would simply become millions of disconnected computers. Which raises an even bigger question: how can one router possibly know the best direction among millions of possible paths?
Imagine a city with millions of vehicles. Every minute, new cars enter the roads. Others leave. Some roads become crowded. Others remain almost empty. Now imagine every driver stopping to ask which road is best. The city would quickly fall into chaos. The internet cannot afford that delay. That's why routers never wait. They decide immediately. Every time a piece of data arrives, the router looks ahead, not behind. It asks one question: what's the best next step? Not what's the shortest path, not what's the most famous path. Simply, what's the best path right now? Because the internet is always changing. New connections appear, others disappear. Traffic increases. equipment fails, entire networks can suddenly become unavailable. A route that was perfect 1 minute ago may no longer be the best.
The next, most people believe the internet has one route between two places. Architects know there are often many possible paths. The router simply chooses the most appropriate one at that moment. Imagine a navigation app not showing one road, but constantly watching every road, updating every second, quietly recommending a better route before you even know there's traffic ahead. That's what routers do for the internet, billions of times, every second, without hesitation, without recognition, without anyone ever noticing. But this creates an even bigger mystery. How can one router know what's happening thousands of kilometers away? Who keeps every router updated about the entire network?
Imagine you're driving across an entire country. Would one traffic officer know every road in every city? Of course not. The network is simply too large. The internet faces exactly the same challenge. No single router knows everything. It doesn't need to. Instead, every router knows only enough to make the next decision. Then, the next router makes the next one. Imagine passing a package, not directly across the country, but from one person to another. Each person only needs to know who should receive it next. Eventually, the package arrives. The internet works in much the same way. Every router receives a request, looks at the destination, chooses the next direction, then quietly passes it forward. Most people believe the internet has one giant brain. Architects know it has millions of independent decisions working together. Each router sees only a small part of the network. Yet together, they create one of the largest distributed systems ever built. That's why the internet can continue growing. No router needs to understand the entire world. It only needs to understand its neighbors and where the next step should be. But something still has to happen. If networks are constantly changing, new connections appearing, old connections disappearing, how do routers learn about those changes without anyone updating them manually?
Imagine an entire city changes overnight. A new bridge opens. An old road closes. A highway becomes blocked. How would every driver know? Someone has to share the news. The internet works the same way. Networks never stay exactly the same. New connections are built. Old equipment is replaced. Traffic constantly changes. Entire data centers can come online. Others may temporarily disappear. If routers never learned about those changes, they would continue sending data along paths that no longer exist. That's why routers never work in silence. They communicate constantly, quietly exchanging information, sharing what they know, learning
what has changed, updating their understanding of the network. Most people believe routers only move data. Architects know routers spend just as much time learning as they do forwarding traffic. Imagine thousands of air traffic controllers continuously talking, sharing updates, coordinating movements, making sure every aircraft can continue its journey safely. The internet depends on the same idea. Not one controller, but countless independent systems continuously keeping each other informed. That's why when one path disappears, another path can be found. Not because someone rushed to fix it, but because the network already knew something had changed.
But this leads to perhaps the biggest question of all. If millions of independent networks can all talk to each other, who decides the rules of that conversation?
By now, you've probably realized the internet has no central controller, no headquarters, no single computer watching the entire network. Instead, it depends on something far more remarkable: cooperation. Millions of independent networks, thousands of organizations, countless routers, all working towards one purpose: keeping the world connected. Every router makes its own decisions, yet somehow those decisions fit together, creating one network shared by everyone. Most people believe the internet was built as one system. Architects know it became one system through communication. Every router quietly listening, every router quietly speaking, every router helping its neighbors understand the world just beyond their own connections. That's why the internet can continue growing. New cities, new countries, new data centers, new networks, joining without rebuilding everything from the beginning. Because the internet was designed not to stay the same, but to evolve, to adapt, to expand, one connection at a time.
And perhaps that's the greatest lesson the internet can teach us. The world's largest system doesn't survive because one machine knows everything. It survives because millions know just enough to work together. Most people think the internet is simply connected. Architects see millions of decisions quietly happening every second. Every request finding its next step. Every router guiding the journey. Every network helping another network. Because the internet never depends on one road. It always finds another. Once you understand that, you stop asking, "How did my data get there?" You begin asking, "What invisible decisions made that journey possible?" Because behind every connection lies a conversation, and behind every conversation lies architecture. This is NextNet, inside the modern internet.